So there's another one, and this one you've probably heard of before, the Mohr-Coulomb. So if you take undergraduate geomechanics, we always talk about this one, right? But now we can kind of cast it in the framework of these other yield surfaces that we've been talking about. So the Mohr-Coulomb is sigma 1 minus sigma 3 plus sigma 1 plus sigma 3 sine phi equal to y cosine phi, where this phi is the angle of internal friction. In terms of the yield surface, this in terms of the invariance, this thing is 1/3 I1. So I1 is the first invariant of the total stress, not the deviatoric stress, plus J2 cosine theta minus 1 square root of 3 sine theta sine phi equal to 1/2, y over 2 cosine phi. So I'll talk about theta is the load, something called the load angle. So I'll talk about what that is in a second, but let me draw this real quick. So again, we'll be like minus sigma 1 So this guy looks like something like that. So it's like the Tresca yield criteria with a pressure dependence. That's what Mohr-Coulomb is. So the load angle is so you see the load angle is also dependent on J3, which again, J3 can be used to delineate tension or compression. And so, could draw it over here, but I think I'll just start another drawing. So if we look at this again, so minus sigma 1, sigma 2. Along the hydrostat, it can be useful or sometimes convenient to kind of visualize this in like a polar coordinate system where you have some distance along the hydrostat, maybe xc, and then if you were to draw a vertical line here that's parallel with sigma 3, then the load angle would be the angle between sigma 3 and the line that's perpendicular to XC that goes up to the state of stress, right? So basically, comparing these two equations, these two drawings, the load angle basically tells you where you're at along the boundary, right, of the yield surface. Yeah, so I'll just write in words, the load angle is controlled by the relationship of the intermediate principal stresses. So that is sigma 1 to either sigma 2 or sigma 3, depending on. And so, yeah, like for example, when sigma 2 equals sigma 3, the load angle is 60 degrees. When sigma 2 is equal to sigma 1, the load angle is equal to 0 degrees. All right. So